I am recording this, so it'll be up online so you have an example of it. I'm going to briefly recap because the program crashed. First thing you should do is label what you can. If we're given anything that's congruent, there's nothing that's congruent, so you start your proof. And we're going to go by the definition of a midpoint, which means that M is in the middle of the segment and it cuts it in half. Midpoints are always points that are going to cut the segment in half. So we were able to say that these two segments are congruent to each other. Now, it also says that M is the midpoint of RS. So what two segments are congruent to each other from RS? Yeah, the RM and then the MS. RM is congruent to MS. And the reason? The definition of the midpoint. And once we have those, we could go into the picture and label those. So this gives me a side. This gives me another side. Now, in this case, I have a side and a side and a side and a side. Am I going to use side, 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 or side, angle, side? Side, angle, side. I would agree with that. But we have to come up with some type of statement for this. Now, what happens, remember I called this type of a picture a bow tie picture. And if we do side, angle, side, there's the side. I have to figure out something about this angle right here. Angle PMS. And then angle QMR. So, what kind of angles are these? What angle pair? Special angle pair? Not adjacent. Vertical angles. So any angles created by two lines, and in your bow tie problem, you're always going to get vertical lines. So, they're vertical angles. So if you have that, we're always going to be able to say that. So I can say that angle, I'll say SMP, is congruent to angle. Since I started S at the end of 2, I'll go RMS. And the reason, definition of vertical angles, that gives me an angle right there. So now we can't just jump. Let me zoom this out a little bit less. We can't just jump to say, all right, well, now these sides have to be the same. We have to actually go through and say, all right, do we have enough information to prove that two triangles are congruent? Yeah, we have side, angle, side. So I can say triangle SMP is congruent to triangle. Since S is at the end of the segment with 2 marks, what would be the first point? What's the corresponding point with S? R. Because it's in the same spot at the end of the segment with 2 congruency marks. And then M and M are right there. And then RMQ. And the reason? Side, angle, side. Now, the nice thing is, Can I say now that QR is congruent to PS? Absolutely. At this point, any corresponding part is congruent in the triangles. So I can say that QR is congruent to PS using corresponding parts of congruent triangles are congruent. The CPCTC. And we're done with the proof at that point. So we're going to be stuck using definitions all the time. So we're going to be stuck using definitions of midpoints, of vertical angles, things like that. Anything shared. The biggest things are vertical angles, shared sides, midpoints, parallel lines. Those are the four big things that we need to deal with. And remember, the goal is we're always going to use our information to get to congruent triangles and then to CPCTC. So we're going to use all that information to get to congruent triangles. And once we get there, the corresponding parts are going to be congruent, whether they're corresponding angles or corresponding sides. We can just jump right to that spot. So, questions on that one?